Good morning everyone. Today I am going to present about feature representation in multimodal system. First let's see what is multimodal system. Multimodal system or AI are computation system that integrate and process multiple type of data called modalities to perform a task or for making a decision. So first let's see what is the difference between the single model AI model, multimodal AI model. Single model AI model, you will have the single data type. Single data type will be fed as input to the single model AI model. So you will get the proper output. In the multimodal AI model, you have the different type of data like text, images, charts. So those all different kind of data will be fed as input to the multimodal AI model. So this multimodal AI model will be accepting all different kind of data to generate the outcome. So that is the difference between the single model and multimodal systems. So first let's see what are the modalities. So there are visual modalities, textual modalities, audio modalities and sensor data. So what are the visual data? So like images, videos are the visual data. So visually we can see so what is there in the image and what is happening in the video, like that we can see as a visual image. And textual data, you know that documents, transcript, these are the textual documents. Audio, so you all know that speech and music are the audios. Next one is sensor data. So sensor data will be different types, LiDAR kind of data, radar kind of data, or IoT streams of data. So like that, you have the sensor data. So these all are the different kind of modalities. Why we need to combine the multiple data modalities? Because the accuracy of the deep learning model has to be improved, as well as the model has to be generalized, and it has to be robust and fault tolerant, richer understanding about data. That's a reason for going to the multiple data modalities. Also, what are the challenges in the multimodal system? Because the data, the heterogeneity of data, temporal and spatial synchronization, we need to synchronize both the temporal and spatial data, and sometimes missing or incomplete modalities, handling the noisy inputs, computational complexity. So these are the challenges in the multimodal system. So these are the some of the examples of real world multimodal system: conversational AI, healthcare monitoring system, autonomous vehicles. So autonomous vehicles will have the different kind of sensors like that is camera, lidar, radar for capturing the input. So we need to combine all those input to generate the proper outcome. And healthcare monitoring system also same way, x-ray, and that initially when the patient comes to the hospital, so they will get all the detail from the patients and they will document it, such kind of numerical data we need to handle it. So for producing the useful outcome, so we need to combine the different kind of data for the particular person or for the identification of the particular disease. Fundamentals of feature representation. So first we whatever information we receive from the that is real-time sources, so we need to represent the feature so that the computer can understand or artificial intelligence technology can understand it. So we need to represent feature, or we need to extract the feature, which involves transforming the raw data into set of features that represent the relevant information for the particular task, which reduces the dimensionality and noise. In the multimodal system, heterogeneous input can be combined or fused for tasks such as classification, retrieval, or prediction. So first, how we can represent image, text, audio and video. How will we represent image? For representing image, we have the different kind of techniques: scale, invariant, feature transform, histogram of oriented, gradient method, color histograms, convolutional neural network. Like that, we have the different kind of method for extracting the image features. So directly, we cannot extract the features. So we have the different techniques to extract the features. Same way, For extracting the textual data, we have the bag of words, term frequency, inverse document frequency, word embeddings. Same way, for audio, MEL frequency, capture coefficients, spectrograms, wavelet. Similarly, for video, 2D convolutional neural network, 3D convolutional neural network. So we have for representing the feature or for extracting the features. So we can adopt these all kind of methodology for extracting the image data, textual data, audio and video. First, let us see what are the approaches we have for feature representation. Classical machine learning, deep learning and hybrid approaches. So what are the classical representation of data? Numerical or tabular data. So we can normalize the data using the normalization or standardization techniques, polynomial data, statistical features. Similarly, for the textual data, we have the bag of words, term frequency, inverse document frequency. For the images, as I said earlier, scale invariant feature transform, histogram of oriented gradients, and color histograms. So these are the techniques for the images. Audio, MEL frequency, substral coefficients, chroma features, or spectral contrast. Similarly, for the deep feature representation, for extracting the image features, we have the vision transformer, convolutional neural network. So for extracting the textual data, we have the word embeddings and contextual embedding methods. For extracting audio, we have the spectrogram based CNN features, Hubert algorithm. Similarly, for extracting the video, we have 2D and 3D convolutional neural network, and we have several pre-trained image models. So for the feature representation, we need to align the data because the time related feature has to be aligned with the spatial related features. So that is the most important. So we need to synchronize the features based on the timestamp or common events such as aligning audio and video streams. So for example, we can take the video. When the video is running, so the text has to be matched with the that video content. So we need to align the features properly. That is the most important thing. Aligning features based on the occurrence of specific events such as aligning text commands with robot actions. Same way, techniques to make, we have the different kind of techniques to make the data stream uniform in time and space. Mainly we need to align all the features based on time and space. So here we can group like time-based alignment, event-based alignment, interpolation and resampling. So these are the feature alignment techniques. And pre-processing techniques also we have, because suppose we have the image, sometimes image will be blurred image and some kind of noisy image, it may not be clear. So in such cases, what we can remove the noise that is unwanted that item from the image, or we can improve the that is intensity of the image. So or we can identify the some outliers values, missing values from the numerical data, and that to be removed. So first we need to clean the data. So once that is done, we need to normalize the data. Scaling is the most important thing to get the proper output. So it is actually scaling features to a common range to prevent dominance by features with larger values. So sometimes there will be variation between the values. Some values will be very small or some values will be very larger. So the AI-based system will find difficulties to handle such kind of data. So we need to normalize it. And the third one is dimensionality reduction. So techniques such as principal component analysis and autoencoders to reduce the number of features while preserving the important information. So these all about the feature representation. So thank you.